Morning, everyone. Today, we are going to talk about another scheduling algorithm that is shortest job first. In the last lecture, we have talked about the first come, first serve algorithm. And we said the first come, first serve algorithm actually have a drawback of conway effect, where if you have a long process that needs to get executed first, then it will take a lot of time on the CPU for execution, and other jobs or other processes of small burst times need to wait for longer duration of time. So in order to avoid this problem, we will try to see another scheduling algorithm that is the shortest job first. So let's try to see this numerical. In this numerical, we have three processes along with the burst time and arrival time is given. So the criteria to solve this numerical is by using the burst time. Previously in FCFS, the criteria to solve the problem was arrival time. But notice here in SJF scheduling, we will solve the problem using the burst time. And the mode is non-preemptive. That means the CPU will execute the process completely whenever it comes to it, and then it will take another process for execution. So let's try to see how it is done. So for these processes, let's try to draw the Gantt chart. So if you notice here at 0 unit of time, so do you see any of the processes that have arrived? No, all the processes will arrive after 1 unit of time. So from 0 to 1, the CPU will be idle in this condition. Now at 1, if you see the process P1 and process P2 have actually arrived. Process P1 and process P arrived. Among these two processes, we will try to execute the process with the smallest burst time. So the CPU will be given to the process with the smallest job. That means the process that requires the CPU for a smaller duration of time. So among P1 and P3, because P1 and P3 have arrived both at 1 unit of time, so there is a competition between P1 and P3 that who is going to use the CPU first. So in the cycle here, the CPU will be given to the process P3 because P3, the burst time is lesser than the P1. So the P3 is now working in the non-preemptive mode. That means it will completely get executed on the CPU. So how long does it get executed? It will get executed for 2 units of time, that is up till 3. 2 plus 1 is 3. If you see, we already have process P1 in the queue, which is waiting for execution. And in between, somewhere in between at this point, you actually have the process P2 that have entered the ready queue. So now, remember, like this Gantt chart is actually your running queue, and all the waiting processes here are actually in your ready queue. So this is your running queue, and this is your ready queue. So then after the P3 gets executed, so now we already have two processes waiting, P1 and P2, because P2 have already arrived at the second unit of time. So between P1 and P2, who will get executed first? So again, between P1 and P2, so you will see the smallest burst time is of P1. So P1 will get executed first. So 3 plus 3 is equals to 6. And then after P1 has executed, then the CPU will be given to the process P2, and then P2 will execute for 4 units of time, that is up till 10. And if you want to write the completion time, now this is a little bit tricky. So you should see where the process P1 got completed. So the process P1 got completed here. So you will write the completion time as 6. What about process P2? Process P2 got completed at 10. So we will write 10 here. And process 3 got completed at 3. So we will just write 3 here. And similarly, you can just calculate your turnaround time, waiting time, and response time by using this formulas. Like turnaround time is completion time minus arrival time, and waiting time is equals to turnaround time minus your burst time. So I have already calculated this for you. You can have a look and cross-verify these numbers. Remember, as we said before, your waiting time and response time will always remain the same because we are talking about the non-preemptive mode. These response time will be different from the waiting time only when we are talking about the preemptive mode. Now, one of the drawbacks of the shortest job scheduling is it also faces the conway effect. So what do we mean by conway effect? So the conway effect means the CPU will be given to some specific processes, and then the other process needs to wait for the CPU. So in shortest first, we are actually giving the CPU to always the shortest jobs processes. Now imagine if there is a long process or a process that requires a higher burst time. So it have to keep waiting for a longer duration till all the short processes or the short jobs will get completed. So this again have the drawback of Conway effect. So this was about the shortest job first. So we will try to see the other algorithm in the next lecture.